Hello and good afternoon. My name's Philip Winstanley. I'm the Principal Security Engineer for AWS Support and AWS Managed Services.
Hi everyone, my name is Manuel Morales. I'm the Principal Product Manager for Technical Products for AWS Managed Services.
And I'm Stephen Bowie. I'm the Senior Security Leader for AWS Managed Services.
All right.
Thanks, everyone. Alrighty, we're here today to talk about rapid detection and noise reduction using automation. So in today's talk, we're going to talk and share with you a challenge we had in our business, the Managed Services division of AWS. We're going to talk about how we worked through this problem, the different solutions we considered to solving that problem. Some of them are not serious solutions, and so we'll share the reasons why those things wouldn't work. We'll talk about the approach that we did take, the benefits of that solution, and some examples of how that solution worked for us. The same problem we were having on our team and in our business, we were hearing the same set of problems from our customers when we talked to security teams at our customers. In many cases, the cloud security teams that we work with and interact with across our customer base, across industries, customers large and small, usually the cloud security teams are very small. Some of the companies we work with are multi-billion-dollar firms, and they have a cloud security team of just 2 or 3 engineers. And with just 2 or 3 people sifting through thousands of threat detections, threat alerts, just wasn't going to work for a team that size. The other challenge that we heard talking with these teams, when they have just 2 or 3 people, they can't operate in a 24/7 way. Some of the customers we spoke with, they'd come in on Monday and spend the first 2 hours of their day going through security alerts that had fired over the weekend. And those alerts could be 12, 24, 36 hours old by the time somebody was actually looking at them. And these alerts could take 3 to 5 hours for them to triage the alert, only to find out that they were being alerted to something that was an authorized user performing expected activity. So they were really struggling with scale. Now in the case where they found an actual threat, an actual issue, it might be 36 hours by the time they had started. And if it was a ransomware attack or another kind of security attack, 36 hours is just too long to start your response to that activity. Cloud environments are also different than traditional on-premise environments. Resources are constantly being created using automation, spun down using automation. It's not unusual for our customers to get a security alert for a resource that was created and then destroyed. And there's really no point in responding to that alert because the resource has been destroyed. And so these customers felt like a lot of their time was being wasted, not on value generating activity, not on anything that was helping their business, but just continually responding to security alerts that weren't adding value. The last problem we've consistently heard from our customers is that manually triaging security alerts just doesn't work. It's not something humans are particularly good at doing in a short amount of time. If I'm getting an alert for credentials being exfiltrated, but the thing that's doing that is a network proxy, that's a known trusted network proxy, I don't need to respond to that. I know that activity is expected, but it could take a human 2 to 3 hours to figure out what's going on, where you could actually do that much faster. Now, in our business, we are managing AWS for our customers, and we're talking thousands of AWS accounts, hundreds of customers operating globally. So the scale we're operating at is an even greater challenge than for our customer teams. We do have a team of folks that work 24/7 globally around the clock, but the challenge they were having was the same one our customers were having. We could receive thousands of security alerts in a week. They could take 3 to 5 hours to process for our people. And what that leads to is frustration when we're seeing the same false positives time and time again. So it's not great for our people. They don't feel good if they can't get through all the alerts. And that manual triage, it just is completely lacking in precision. As an example, the first time we ever saw a compromised Windows server that we were managing on behalf of our customers. There was an alarm for the CPU spiking. There was an alarm for memory, free memory being too little. We had an alarm from the endpoint security agent, and we had an alert for guard duty. And all four of those alerts, all four of those tickets went to 4 different people who were all working on different parts of the same event. So just really imprecise when you're using humans to do that initial triage and when we're operating at the scale that we're operating at. So, a couple possible solutions to this. The first one we talked about was hiring every security engineer on Earth. And our finance team was not really impressed with that idea. It also doesn't solve the problem that I just mentioned, the lack of precision. Sure, we could have lots of humans, but they're still taking 3 to 5 hours to triage a security alert when we want to be faster than that. And they just don't have the knowledge in their heads of all of our customers' environments. Second idea was to ask our existing team to work 24 hours a day, 7 days a week, including holidays. And our HR department was also equally unimpressed with this idea, as was my team, who all threatened to quit. Third idea, hey, let's centralize the logs from all of our customers into a central account. But now we've got a problem with shipping logs all over the place. That gets very expensive. We're also operating, like I said, hundreds of customers, and we didn't want to commingle all of their logs in a central location. That just screamed a bad idea for a security team. Privacy implications, sovereignty issues, et cetera, et cetera. Magic unicorns was discussed, but we didn't know where to find them, so still not really a practical solution to our problem, so not something we pursued. The last idea we discussed was automation, and this is something our team understood. It was a great way to make use of our humans and our engineers to take patterns we knew and just automate the day-to-day tasks that our team is normally conducting and normally performing and make it go faster. So with that, I'm going to ask Phil to come on stage and share with us and you what we built.
Thank you, Stephen. I'm very excited to walk you through what we've spent the last couple of years building out in terms of automation to solve for these challenges. Before I go any further though, can I just get a show of hands for how many people are involved in security at all in their organization? Oh, most of you, cool. You're in the right session then, that's a good place to be. Fabulous. All right, so this slide is a great example of why you let engineers make decisions and not our managers make decisions, right? We want to make sure the engineers are making the good technical choices and driving things through. So let's walk through what some of those were. We decided to really aggressively automate the work that our security team was doing. There's loads of really undifferentiated heavy lifting that we found our engineers doing, especially the tier 1 SOC analysis work, which is looking at log files, which is checking IP addresses against threat intelligence databases. It's all the stuff we do again and again and again. So we worked with our engineers and we found opportunities to automate these tasks that they were doing. And we automated away that undifferentiated work. That gave us an opportunity. Because we now were using automation and not people to think about those tier 1 tasks, it meant that our automation could have a much bigger addressable memory space to think about things. Our engineers needed to hold everything in their heads and they had contextual knowledge about things that were going on. But our automation could access every database we've got, every knowledge base that we have access to, every ticket that our customers have previously worked with us on, or any cases that we've had. So our automation was able to do much more. And that created a possibility for us that our people just couldn't do, which was starting to look for known good behavior. And what do I mean by known good behavior? Well, threat detection systems, any tooling that you're using that's creating findings, it's looking for bad generally. It's looking for anomalous behavior, it's looking for malicious activity, it's looking for items that match threat intelligence databases. And those come through. So the work to find the bad has already been done by the time the alerts and the alarms are coming through. The problem we found is about 99% of the things that were coming through, whilst they were true positive detections, they were false positive in terms of malicious activity. It was a developer deploying a new stack. It was someone coming in on the weekend to do a bit of work. It was someone on a plane using the plane Wi-Fi to log into their account and make a change. Please don't do that, by the way. It's a terrible idea. But what we found is there were there were activities that people were doing that was known good behavior, known networks that they were coming from, known files and systems that they were using. Beautiful example. There are pieces of backup software out there that when you run them on your system, they look really similar to crypto ransomware software because they iterate through all the files really fast and touch them. And a lot of threat detection systems trigger and go, oh, looks like you've got ransomware encryption happening, when in reality it's just your business backing up data that you know about. So we were able, with that tier 1 analysis, to start to bring together some of that knowledge. And not just at an industry level, but specific to each customer, their accounts, their workloads, their services. We started to learn about what they were using inside their environments, what common patterns of behaviors they have. If they're using packet inspection and they're routing it through one of our partners like Zscaler, then we knew that that was the network route that they'd got set up. So we started to build knowledge bases of this information. As I mentioned, our people can't keep that knowledge in their heads, but a machine can go and look that knowledge up at any point. The next thing that we did was we started to understand that it wasn't good enough for 1 or 2 people to own how do we do investigation, how do we do triage. Because each security engineer, each analyst has got their own techniques, their own approaches. They've got a lot of institutional knowledge that we want to get out of them. And you can have 1 or 2 developers writing scripts, but the developers aren't the security engineers that are actually doing the work. So we worked with our security analysts, and with the time that we freed up, where they weren't doing the tier 1 analysis work, we actually got them to learn coding. And in our case, Python. Python's a very, very easy language with an easy onboarding to. So we worked with our security teams, and I'll be honest with you, some of our analysts were a little bit resistant at first. They didn't want to learn a new skill. They were happy where they were. But we worked with them to say, hey, listen, coding is so important, and it's going to be so important going forward as well. And we want you to expand your horizon and embed in this. So we asked our engineers, if you can take that domain knowledge that you've got of how you like to run investigations, about how you like to approach things, and capture that in code, in automation, and then let us use that at scale, it means we can have you running 24/7. Your skills, your knowledge, your expertise applied on a consistent basis. So we were able to pull all of these things together and all of these potential data sources together, which meant we were able to eliminate all of these repetitive tasks at the low level. Now, a lot of words there, a lot of talk I've just given you. This is reInvent, so it wouldn't be a talk unless I gave you an architecture diagram with a bunch of colored icons on it. So let's walk through how we've gone about this. And you may have seen this week, there's been a service launch called AWS Security Incident Response. That's the service that we built out, and it's powering AWS managed services and our security capability for all of those hundreds of customers and thousands of accounts that Stephen mentioned earlier. So let's walk through what it's doing and how it's actually operating. We have Guard Duty, we have Macy, we have Route 53, and then we've got third-party providers that produce tools. And everyone's got a rotation of whichever flavor of the month tool is in use in their organization. Normally about a year to 2 years, and then people swap them out, there's another tool. We've got lots of different data sources for that threat intelligence. And no one analyst can keep all of that in their heads in terms of all the different finding types and all the different problems there. So what we did was we worked with Security Hub, and we made sure that all of the findings from all of these disparate sources were coming together into one place. And AWS Security Hub is a fantastic platform for aggregating all of those findings. It does a great job of deduplication, of storing things there. It's got workflow management. It's a really good point to bring everything together. But we've still got the problem that we've got thousands and thousands and thousands of findings coming in every single day. And again, we can't ask analysts to do that. So we built out AWS Security Incident Response to handle that middle tier piece of the triaging and of stepping into all of those findings, accessing all those different data sources that we have access to, threat intelligence and other pieces, and then pulling that together. So digging into threat intel, not just from across the whole of Amazon, but also third parties and other things as well. digging into CloudTrail and other logging sources, NetFlow logs, application logs, other different systems that might be available to us, and pulling into those and pulling that together. It's really a virtual security engineer or a virtual analyst that's sitting there in the middle of this pipeline and doing all that undifferentiated heavy lifting. And it's doing it completely touch-free. You turn it on, you point the event bridge at it, and it just starts working and pulling that data through, building knowledge up. But we still need responders. It's still super important that we have people with security knowledge and domain knowledge available to be able to pick up those events where we're not sure if it's known good behavior, or we think it might be an actual compromise, worst case. Now, thankfully, we don't get too many of those because we do a lot of work up front to work with our customers to make sure that their environments are proactively protected, that the posture management is in place, and that other things are happening. But we still need those responders there. So what are those responders doing now? Well, as well as picking up those tier 2 and tier 3 activities, the really deep, intricate investigations, they're still working to take that knowledge that they're learning as they go through each one of those and then feeding that back into the system. The system's a closed loop. It allows us to feed our knowledge back in and make sure that our responders are continually growing, but also continually contributing back to the system, but not having to do the boring thing that they've done 1,000 times already this year. They're not having to go and look at those logs, not having to dig into the threat intelligence source. The system's doing that for them. For our teams, this was a tricky journey. As humans, change is difficult. It's hard to adopt new systems. It's hard to adopt new things. And people worry and have concerns about what would a system like this mean for me? If I'm a responder sitting there at my desk, am I going to lose my job? What's going to happen? And when we started working with our team on this, we had to go through that journey with our team and work out what are the challenges that we've got there. So let me step through some of those challenges that we faced and walk you through how we overcame them. Because what's key, what's important for this session and for you to take away as part of this is you can go away and do this today with the platforms that are out there that AWS makes available to you. We're talking about our managed services business, but we want to make sure that we share with you how we're doing it so that if you decide to go and do this yourselves, you've got some of that best practice. But these human challenges, the people conversations, if you go away and want to do this, you're going to have those same challenges in your organizations. So I want to share with you how we approach those and what we did to kind of get through that. So, as I mentioned a few times, and I'm a security person myself, we don't like change. We like things to stay exactly the same, we know what they are. This was a novel approach for our responders, looking for known good behavior, looking for the things that we expect people to be doing versus looking for malicious activity and for threat actors. So there was concern amongst our responders about doing something that's not industry standard. It's not the way that you were taught to do this. It's a very different approach to things. And the way that we overcame that thinking with our team was by sitting down with the data, was by looking at all of the findings that are coming through and then running data science and analytics across those findings and actually working out if we, say, for example, said everything coming from that network endpoint of this finding type with this kind of payload in there, do we know that's known good behavior? We do, because we've checked with that customer. They've confirmed that that's the way their networking is built up, that that's a known good piece. Okay, so if we eliminated those from our thing, what would the reduction be in our data set? And for some of those, it was as high as 80% reduction in the findings we had to address just by looking for a few common patterns of behavior. But that then introduced a new problem, which was, but what if a threat actor uses that same technique and approach and the same network and is in there and is going through all of this? And that is that fear of missing out. What if we miss the actual malicious activity that's going on inside that space? And this is the one that scared me the most. As the person driving and proposing all of this, if I missed an actual compromise, that would hurt. I'd feel that in my core. And more importantly, my customer wouldn't be in a good place. And that's the last thing that we want. So again, we turned back to the data. And we said, okay, today, how many findings are we able to look at? How many are we actually looking at? And when we were truly honest with ourselves, it was something in the region of 10 to 12% in those early days. In our heads, it was 90, 99%, but when we actually looked at the data to see what we were truly touching across all of the different finding types that we were addressing, and Stephen mentioned earlier, CPU alarms, memory alarms, disk getting full alarms, all these operational alarms, as well as the security alarms, we were touching a fraction of them. The new system meant that we could cover near 100% of them. So our fear of missing out was offset by coverage. We increased our coverage, which meant that the likelihood of us missing something actually reduced, not increased, even though we'd flipped the approach on its head looking for known good behavior. I mentioned the third one already in terms of job security. Engineers are like, so you don't need me anymore. And actually the reality was, we need our engineers more now than we ever have. We've actually increased the number of security engineers that we have, even with this, because the way that they're able to contribute by providing that security domain knowledge and helping us build out automation, build out new pattern matching algorithms, thinking like threat actors think, which is something no script is ever going to do. We've been able to actually secure the jobs of our engineers even more. They're even more valuable than they've ever been. And none of my team are here to represent themselves now, but they'll tell you their workload's increased, not decreased, because I found more interesting things for them to be doing than looking at log files all day, every day. But it's more interesting work. It's more fascinating work for the things that they're focused on. And then the last piece was transparency. And what do we mean by that? We were concerned that if we set the machine off and it starts working away, how will our customers know what's happening? So we had to work out, how do we close the visible loop? How does our customer know that we've looked at that finding, that we've checked it, that we've worked through it? So we had to find ways of writing that data back to somewhere that was visible to our customers. And thankfully, in both Security Hub and Guard Duty, they both have the capability to write back what you've done with a finding. So we've been able to take advantage of that capability and then write that back. That means when our customers are looking at these things, they can see what's going on inside that space. But this wasn't an easy journey. And my engineers have taken time to come on board with some of this and to work through it. And these are all challenges that you might face in your own organizations as you come to automate and move into a tier 2, tier 3 space for your engineers. Just bear some of these approaches in mind as you're going through it. Right, let's talk a little bit more depth now about what we've truly achieved with the system and the platform. So, it turns out when your engineers aren't looking at logs all day, every day, and they've got that glazed look on their face, they actually get excited by doing something more interesting. Our engineers truly have jumped in on the work to actually automate, and to automate as much of their work as they can. Because everything they automate makes their lives easier, and they're able to keep on moving on other areas. We've also seen a huge reduction, 100-to-1 ratio reduction in the noise to true signal ratio by using that known good behavior approach. We didn't think it was going to be quite as good as it was. We've been surprised about how powerful that really has been. But because we've got those awesome tools like Guard Duty and other systems doing the detection, and we've got that data about our customers, their systems, their workloads, their organizations, putting those two things together has allowed us to eliminate so much of that signal. So we're focusing on those ones that are left over. And that's where the threat actors are going to be, if they're anywhere at all. So noise reduction has been incredibly powerful for us to decrease the number of things that are coming through, and therefore the number of escalations that involve other teams. What we found previously was every finding that would come through, we were reaching out to the application team that owned the application, sometimes getting them out of bed at 2 in the morning, which they do not appreciate. And we've managed to reduce those significantly down. So we're actually less noisy to our on-bound partners as well, and the people that we're working within our organizations. The other piece is that it was taking a lot of time to do this. Thousands and thousands of hours every year, numbers of headcount and people time available that we've now got back. And we're able to free these people up to go and do more interesting work, use their skills better. And when you're working with your own engineers, they'll tell you, hey, if I had more time, I'd love to do this, whatever that this is, a side project, some innovation, driving the business forward. We freed up our engineers to allow us to do that. And Manuel will touch on a little bit more of that later on. And then, because our engineers are able to free up that time, we're able to move more into proactive work. What do I mean by proactive work? We're able to look at the posture of our customers' environments and shift left in that life cycle. And we've been able to actually make the environment safer, which has reduced the number of findings coming in the first place. So it's a beautiful virtuous cycle of things feeding back on themselves. And we've got examples where we had customers that were struggling for years to move the needle on their posture. And by working with us, we've been able to not just reduce the number of findings coming through, but also improve the security of their environments in a measurable way. Whether that is replacing the instance metadata service version 1 with version 2 across all of their instances, or working through their S3 bucket estate and making sure things are configured correctly and are locked down appropriately, or even just simple things like making sure there's MFA on the root users on their accounts. We're able to free up time to be able to focus on those preventative areas. That means we'll get less events throughout the entire system. And then lastly, the ability to learn from each event. And this one's probably the most powerful one that we have because of the scale that we operate at. When a customer does have a bad day, when a compromise does happen, or with a near miss where something nearly happened, we take that learning and we're able to build new automations to detect it earlier in the kill chain, to the point that we are finding things much faster when they're happening. I've got an example of a customer that came on board and they'd had a really tough couple of days. They'd got compromised, somebody got into their environment, and there were a bunch of signals that happened throughout their compromise event. Guard duty fired to say, hey, you've got some recon activity happening, someone's scanning the address range and probing your servers. There was a guard duty finding that came through and said there's an instance credential exfiltration happen. That means that the instance that should be used on the credential that should be used on the instance is being used from somewhere else, another country entirely. It wasn't even coming from the instance anymore. There were findings that showed that that anomalous IAM activity was happening. So the threat actor was looping through all the regions in the account, checking what was enabled, what permissions did they have, probing S3 buckets, seeing what was available. And ultimately there were findings that came through and said, hey, there's data exfiltration happening. We're seeing loads of data leave your account and going off to that source over there. Now, the customer in question had guard duty turned on, they had Security Hub turned on, they had all these things there, but their analysts didn't get to the findings in time. They got to them a couple of days later. And it was really sad to see the impact to that customer. They lost a lot of data. It was encrypted and they never got that data back. But what we did with that customer was we took that kill chain and we looked at all of the automation opportunities to inspect every single signal that existed in that kill chain. And we built those automations in. The same customer, a year later, had the same threat actor try it again. And we caught it on stage 1 of that particular piece. Now, it wasn't just that one customer that benefited from that work. That capability went out to all of our customers. So we're able to do that for everyone. So every time we learn anything, all of our customers benefit from it, and we build that into the service so that we can do that. So it's that availability of engineers, it's that innovation mindset, and it's learning from the scale that we're operating at and bringing all of that together. Okay. Let's talk about some scenarios now. And I'm going to walk through 3 that are real. No names, but these are real scenarios, real customers where we've had things happening. Let's talk about this one first. So port scanning and reconnaissance activity. Reconnaissance activity as a security engineer is the bane of my life. It is the noisiest part of any detection system. It's the equivalent of if someone's walking down the street and looking in the windows of cars, setting off an alarm every time someone looks in the window of a car. And we don't want to respond as responders every time that happens. But when we've got security tools, that's what we feel like we have to do. We feel like we have to respond to every single recon activity. And you know what? We need to put stuff on the internet. We need things on the internet so our customers can consume them. Whether it's APIs or services or systems, we can't put everything in a nice, safe, secure box. It's got to be exposed in some way, shape or form. That means that reconnaissance activity is going to happen, and it's going to happen a lot. So where we've got instances, EC2 instances that are sitting there and they're exposed to the internet, and they're deliberately exposed to the internet. And we've got other instances that might be elsewhere that are creating network activity that looks like port scanning. There's a variety of reasons that might come in. It could be genuinely some threat actor is scanning your environment and looking for a way in. But that's happening all day, every day. If any of you have got anything exposed to the internet, you'll see that all the time. And it just becomes noise to the point that you stop looking at it. And that's not cool. It's not cool that you stop looking at it. So how do we reduce the address space of those findings down? How do we focus on just the ones we want to take care of? Well, we know our business, we know our organization, we know the workloads that they've got. We know where the traffic is routing from and to on a continuous basis. We've got all those log files, those really rich log files full of data. And we're able to look into those systems and identify, hey, this instance always talks over these weird ports to that other instance over there. It's absolutely fine for them to do that because we know that both of those systems are designed that way. The application's built that way. It's designed to do that piece of work. And then we see that traffic flowing between the two. That means that it's designed to do that. Now, what are the examples that we see this on? And there's a couple on the screen here. It's us, it's security folks. We're the ones that cause so many of these. We do it to ourselves in many ways. Penetration testing. We go and we buy a third-party service and say, hey, please scan my addressable space and make sure nothing's left open. And they generate findings. Then our responders don't know that we're paying that company to do it, so they start jumping on them and responding to them. So we've built a lot of knowledge into our systems to start to understand what does good recon activity look like versus bad recon activity. And again, because of the scale that we're able to operate at and all of the different customers we're working with, we know who the big providers are. We know what IP address ranges they're using. We know the signature of the traffic that they send. And we're able to identify who's doing what inside those systems in a way that would be too cumbersome or too onerous for individual organizations to collect all of that data and pull it together. We're able to do that at scale and pull that through. So this is an example of where that recon activity we're able to reduce down massively through that tier one automation and through collecting that data across our customer environments. So truly something unique to AWS's scale that we can perform this capability. Let's talk through another example here. We've all seen Bitcoin, especially recently, the price has been rocketing up. And that's an attractive piece for threat actors. No one wants to pay to mine their own coin. But if someone can compromise your environment and either spin up resources or co-opt your existing resources to perform that crypto mining, it's a really common attack pattern that we see happening across the public cloud and all public cloud providers. And to actually do mining in the cloud is not cost effective. If you go and get an AWS account, you spin up an instance, you want to do mining, we will charge you more than you'll make on mining. It's generally the way that it goes. So very few people use the cloud legitimately for mining. It's pretty much always illegitimate activity when it's happening, but not always. And that's the key thing here. We had a customer on board to us, a financial institution that came on, and within minutes of them coming on board, our system lit up like a Christmas tree. Lights came on everywhere. They're like, there's crypto mining happening. They're talking to all of these crypto pools. Like, crikey, what's going on? We got in touch with the organization rapidly and worked out they've got a research division that is working on their own cryptocurrency. And they're working heavily with different blockchains on different coin networks to work out the most efficient ways in which they can use those ledgers and pull that together. Now, that's a pretty niche use case. But it turns out they weren't the only one. We've had multiple customers that have come on board. As people are using blockchain more and more to use it as audit ledgers, to use it as distributed control of data, we're seeing more and more people talk to blockchain networks and crypto networks where these things are hosted and actually use them as data stores. So we've had to build up knowledge about this and build this into the systems. And it means that our investigators are no longer panicking every time we see one of these because we know that it's from that workload and it's supposed to be talking to those things. And again, that pattern, that behavior, we're able to build that into the system and look for it going forward in other areas. So the next customer that comes along and wants to build a ledger-based application that's talking to a particular mining network, we've got them covered, and we're able to do that without having everything fire off again. And then probably my most interesting customer that we've worked with. There's a customer that we've got, and they do search engine optimization. I don't know if, for those of you that have been around for long enough, we used to have to do all sorts of weird and magical things with metadata and making our web pages visible to search engines. But now it's mostly done by a few companies, and they go out there and they crawl the web on behalf of you, you pay them, and they make sure your pages are optimized in the right way. Web crawling is inherently quite dangerous because you don't really know where you're going to end up. You hit a page, it's got a bunch of links on it, you then go to one of those links and you follow those links, and before you know it, you're on a malware website. Turns out that leaves a lot of DNS traffic data in logs, and our threat detection systems that are focused on that DNS traffic data were like, oh my word, these guys are visiting every bad website in the world, and they're doing it really fast. So we were very quick to identify with this particular customer, certain workloads in their environment were doing this crawling. And our initial response was like, are your systems okay? Because they seem to be talking to some really dodgy stuff. And it turned out, yeah, they were absolutely fine. What we were able to do with that customer was work with them to help them harden their environment so that just in case anything came through, it wouldn't be able to be executed inside their space. So we're able to work with them to make sure that the actual crawlers that they built out were hardened to the kind of things they were likely to go and see on the internet. But it also meant that we were able to reduce the noise to our responders, because we were able to go, okay, we expect that system to go and look at malware websites. We expect that system to go and crawl onto weird and wonderful places of the internet that no people should ever be touching. And it allowed us to then free up their time. In most organizations, this is so tricky and so challenging. But because we're doing it at scale, again, we're able to see these patterns, identify them in one organization, one customer, and then replicate it across our entire fleets, and then work with any other customer that might have a similar type of use case. And people are coming up with even more weird and wonderful things every day, especially with generative AI. We're seeing some awesome implementations coming out of our customer base that's creating new patterns of behavior that systems just don't perform normally. So by looking at this, looking at it at scale, having this feedback loop and driving things together, we're able to really improve on what's going on in our environment, in our systems. That means that we can reduce the amount of time it's taking for us to find the bad things, because we're not looking at this anymore. We're just looking at a much smaller subset of data. It means that when we're looking at that subset of data, we know what we've eliminated. So our investigators are already starting with a massive head start. We say, hey, we've checked these 100 things already, and this was the results of them. They're already ready to start making decisions on what's going on without having to go and look for anything. It also means that our people are having a better time in life. They're able to really use their security knowledge and security expertise to make high judgment call decisions. And we've empowered our people to use their skills in a way that they could never do when they were so focused on looking at log files, looking at threat intel from an IP address, looking at these very small pieces. We've opened up a whole world to them and given them the ability to grow, scale, learn new skills, and engage on other technical challenges that we have, including that proactive work that we might want to have in place. So with all of this, I'm going to hand over to Manuel now to kind of walk through what we're calling the virtuous cycle of this system. And I will hand over right now.
Thank you, Philip.
Thank you so much.
Right. 2 or 3 years ago, when the AMS team, our team of engineers, started looking at this approach, we would have never imagined that we were going to be able to monitor all of our alerts, even twice as many alerts as we were receiving back in the day, and just at a fraction of the time. Today, that's the reality for us. What seemed to be an impossible goal for us It's now our everyday activity. So what we want you to get is to imagine your team having to stop chasing every single alert and just moving towards more strategic approach for your organization. This approach for us is not only about triaging alerts or reducing the time it takes, it's about enabling our teams to move to more strategic things. We have created with time what we call at Amazon a flywheel effect. A flywheel effect is pretty much a virtuous cycle, a learning mechanism, a system that feeds on itself and it just gets better with time. So we want to share with you what happened from our perspective, what we think the effect will have from your perspective too. Everything starts with security events or alerts. We all have them, we have to monitor them, we have to investigate them. Depending on how good of a job we do, we're going to improve the customer experience. Our customers are going to be happy. If we don't send them a lot of noise, they're for sure going to be happy. If we detect everything bad that is going on in the account, they're going to be happy. If when we detect those things, we send them enriched alerts, not only do we just notify them or forward them the finding, we enrich that alert for them to take actions, they're going to be really happy. When customers are really happy, they start onboarding more workloads into our environment, into our service. It is common for us that we get customers who start with just a small handful of accounts that were maybe impacted by a security incident, and then expand towards more workloads over time. We usually see also customers who move from one company to another, and the first thing they do when they move to the company is enable our service. Now, don't necessarily, the flywheel still applies for you if you work in a single organization, right? Because you still have the security findings. If you send good alerts, if you do a good job on investigating and analyzing all of those alerts, your development teams are going to be happy. Your stakeholders are going to be happy. They're going to be proactive and reaching out to you and making sure that every development, every release that they do is going to be monitored by you and your team. And then for us, and also for you, when we get more workloads, when we get more things to monitor, we also have a diversity of findings that is coming from our customers. We've seen everything. Our team, I'm sure Philip was amazing at bringing up a lot of examples because we've seen a lot of different things. We also have customers who are using a multitude of tools. That means we get better at detecting things, but that also means we get more alerts. Now, the flywheel here is incomplete, and you can see that it can very quickly spiral into a very negative thing. If you just get more alarms, and then your team is doing the triaging manually, your customers or your stakeholders are not going to be happy. They are not going to send you more things to monitor. You are not going to have the bandwidth to maybe license that amazing tool that was just released. And then it's just going to be bad. But after implementing the approach or the recommendation, automating all of that good known behavior, you're going to see a lot of benefits from that. The first one, well, for us, it's lower prices, but don't necessarily think of it from a financial perspective. You will free your teams from having to look back in the past of what has happened in the last 24 or 48 hours to look forward. Instead of taking a reactive approach to every single alert, they can start focusing on being more proactive, on being more preventative. What are all of those projects? What is all of that tech that you and your team has to work on? If they have the automation looking at everyday work, they're going to have time to do more strategic work. It also releases your team to focus and innovate on new things. I don't know what is it that your business is doing, but I know that your team of engineers are going to find amazing ways of finding a good use of our time. As for my engineering team, they found good use of our time. So we are very excited to announce today the launch of AWS Security Incident and Response. This is a service that was launched just yesterday, and it's available for all customers via the console. This is in response to feedback from many of AMS customers who wanted our security capabilities, but maybe didn't want all of the operational capabilities of AMS. The service is comprised by three main features. The first one, you guessed, is the automated monitoring and investigation of alerts. We monitor alerts from GuardDuty and supported third-party tools via Security Hub. We get those alerts from your accounts. We determine whether or not they are good behavior or they need to be escalated to you. The service also has a console in which you can centralize all of the security incident management. So you can define who has access to see those security incidents. You can assign permissions to them. In the console, you can centralize all of your communication. You can share logs, you can share files in a very secure way, and basically track every single step of the security incident. Finally, you will get access to the experts, 24/7 specialized security experts who will not only be proactively monitoring your environment, they're going to receive all of those alerts that our automations were not able to triage. We're going to enrich them. We're going to do the investigation and contact you if we need your help, if you need to be informed about what's going on in your environment. On the other hand, if you need help, if you need us to investigate anything, whatever it is, maybe you see something in another cloud environment or on your premises, and you see, can you check on my behalf whether there's something going on in AWS? You can also cut us a case. You'll have access to 24/7 team of experts. We're going to respond within 15 minutes to your cases. Of course, it's your decision whether or not you want to build these capabilities by yourself with your team or you want to use the service. But if you're interested in learning more about the service, we're going to be presenting more about it tomorrow at noon in the Mandalay Bay Ballroom. So please make sure you bookmark that presentation for you to learn more. Thank you very much for your time. We're going to be spending some time here for you to ask us any questions that you may have about our approach, the new service, or just our experiences. Thank you. Have a great rest of the event.